Good morning, everyone. I am Vincent Legros, Marketing Officer at Mercator Ocean International, and I am pleased to welcome you to this debriefing session of the WEkEO Training Focus on Land Data Products. So today I am with Amin El Amrani and Geoff Smith, both of them WEkEO user support experts. So they are here to answer all your live questions, and they might be able to answer all your questions. So quickly, the agenda of this debriefing session. So after my short introduction, we will display a live survey, okay, where you will be able to answer the question. So this live survey will has the objective to know more about what you did during this training. Geoff Smith and I will comment the results afterwards. And after, Geoff will do a short recap of the training session. And we will launch the question related to the content of the training session and the IT infrastructure with Amin. So, quick reminder, this is the format of our training. So we are in round 3, the debriefing session. You should have participated in the round 1 webinar session and did your homework during these 3 weeks. So this debriefing session is aiming to answer all your questions you could have during this practical homework. So quick reminder in terms of material we can provide. So we have our YouTube channel where you can find all the recording of the webinar we did since since last year. Sorry. So you have webinar number 1, 2, 3 dedicated to beginners, and as well thematic webinar, marine, atmosphere, climate, and land, of course, will be available soon on our YouTube channel. So the basic rules for attendee, for the participants who come first time to this training session, we have a Q&A enabled for you, the participant, to ask question anytime you need or anytime you want during this debriefing session. So bottom right of your screen, you just need to tap your question, and during the interactive session and during the Q&A, we will display the most relevant question, and Geoff and Amin will answer your questions. So this is how the question will be displayed on the main screen. You can, of course, visit our website, wekeo.eu. We have our Twitter account as well, at WEkEO-DS. And of course, you can join the service desk anytime you need at support@wekeo.eu. So let's begin. If you don't mind, we will begin by a survey. So the survey will be displayed soon. Geoff, I leave you the floor to comment the question, and you, the participant, you can scroll down and begin to answer the questions. Geoff?
Okay, thanks. Good morning, everybody. What we're going to do is just ask a few basic questions about how you use optical Earth observation data to kind of get your thoughts and feelings, and to try and understand the sort of the landscape of the people that are involved in the call. So if we now look at the first question, have you processed or analyzed optical EO data as part of your work, and at what scale? So we're just trying to look here at what the experience of people is. You may not have used data, so if we have an answer for that one. But we're looking to see if people are working at small scales in terms of sites, what we refer to as national or regional scales at a country or sub-country level, or if you're working at continental scales, and then finally globally, because that often then controls the types of data that you will use and the types of analysis that you will undertake. And great, so we can see as presenters here that the answers are coming in. So please keep answering those questions. The second question is, what spatial resolution do you use the most? And this again relates to the types of instruments and sensors that you'll be using. So we have 4 categories here. Very high spatial resolution are those things that are less than 10 meter pixel size. These are mostly commercial systems or airborne sensors, aerial photography, etc. High spatial resolution is between 10 meters and 100 meters, and this area is dominated by the Sentinel-2 and Landsat systems, or things like the LISS from India, or the French Spot systems, which were more legacy systems now. And then at the medium resolution, this is between 100 meters and 500 meters, and this is similar to Sentinel-3 or the US MODIS systems. And then finally, low spatial resolution is more the domain of the weather satellites at greater than 500 meters, such as the NOAA AVHRR, for instance. Okay, the third question is, how do you use multi-temporal data in your work? So we can often work with just a single image and produce a product or a service, or we may use dual data imagery, for instance, summer-winter imagery to show phenological change, or before and after an event if you're working in, say, the emergency domain. And then finally, there's time series analysis, where you will use multiple images greater than 2, possibly up to hundreds of images together to show how the landscape changes over time. A question now about whether you've been able to use or edit and practice with the Jupyter notebooks previously that we showed in our original training session. And then we always expected you to edit and work with those Jupyter notebooks. And so here's just some questions about potentially different work you could do using that original Jupyter notebook as a framework. So the first one is about displaying images in different band combinations. The second one is about calculating different spectral indices to show up different properties of the surface. The third is about how we display data in terms of translating digital numbers into color values for better interpretation. And then the final one is whether you have compared different products in different outputs in a way not shown in the original notebook. Okay. And so the final question is whether you'll let us know your comments. So please add those into the Q&A or box on the system. And but also we will be available after this session through the normal WEkEO user support systems to provide any answers to this or the previous Jupyter notebook, or any other aspect of the optical and land domain activities within WEkEO. So I think we are progressing nicely there. Do we have a? So we have. Go on.
Yeah, we leave 1 or 2 minutes for the participant to fill up the survey, Geoff.
Yeah, no, that's fine. Yeah.
And after we will share the results with them.
Okay, that's good.
So yeah, I leave just 1 more minute for the very last of you to fill up the survey. Okay. A third of you have voted so far. So the 2/3 of you, the participants, if you don't mind to fill up the survey, it should be great for us. Thank you.
Vincent, is there a complete survey button at the bottom, or I'm just wondering, just in case people have maybe answered the questions and then not submitted their answers.
No, it's quite easy for the participant to fill up. There is no question or interrogation point, so no worries about that.
Okay, that's good.
If you don't mind, we will end voting and share the results. Anna Maria, please, can you do it so? Okay.
Okay, that's great. Well, that's nearly half people who are involved, so that's good. Thank you very much for your answers. So if we just quickly now review those questions, we can see for that first question about the sort of scale at which you're doing your work, it's focused mainly around what we refer to as the local site scale and the regional to national level. So I think we only had 1 or 2 responses working at the global level. And interestingly, none at continental level. So maybe there's a gap in the market there where continental level products would be appropriate for certain applications. So, but this is fits with how a lot of projects do develop, where they're tested at the site level first of all, and possibly rolled out to regional, national levels as the next step. So that makes sense there. In terms of spatial resolution, very surprisingly here, we have no responses of people using VHR data, very high resolution data, which is actually the more historically, the more widely used data sources, because it is very comparable to aerial photography. So lots of work in the past was done with air photo interpretation. So that's quite unusual. But then we are then clustered around this high and medium spatial resolution. So at the high resolution, that fits with the site level to national, regional level mapping. So that's positive. And then the medium resolution work is perhaps more to do with global, large, not necessarily global, larger area vegetation mapping. And certainly with the development of the Sentinels and their image acquisition capabilities, we're now seeing a trend for even global applications can now be driven by high spatial resolution data, whereas in the past they were the domain of the medium and low spatial resolution systems. So that's a positive sign as well. So in terms of using multi-temporal data, very positive again here, this time to see that the time series are being exploited by lots of people on this call, because that's one of the key advantages of going over to constellation type systems such as the Sentinels, where we can increase the revisit frequency so we can collect more imagery over time. That then allows us to track natural and anthropogenic processes, and also detect subtle changes, or even where we have a subtle change, the fact that we're imaging that site at multiple times allows us to have a greater confidence that the change we're mapping is correct. So that's also good to see. Just over half of the respondents were able to work on the Jupyter notebooks. So that's good to see that people working on them. And if anyone has any comments or issues on those notebooks, please feed those back to us. We can build that into future training activities and demonstration notebooks, etc. So that's great. Okay, in terms of how the notebooks would be edited, lots of people, well, a number of people are interested in calculating different spectral indices, and also comparing how those indices look for a particular location. So we'll go on and run through the previous training course, Jupyter Notebook, showing some of those updates and how you may go about doing some of those different activities there. So yeah, so the last question was really more of a comment or a request itself. So yes, again, please feel free to let us know any of your experiences or comments from using the notebooks, anything we could do different, or anything else you would like to see. So that's always useful to know. So thank you for that. Thank you for responding to that, and we'll keep these results on file and use them in our future decision making. Thanks, Vincent.
Thank you, Geoff. Thank you very much. Thank you for the participants who have answered this survey. So, but we will continue with you, Jeff, and I'll leave you the floor, and you will do a quick summary about the training session.
Yes, I'll just need to share my screen. Okay, can everyone see that now?
Yes, we can. Yeah.
Okay, brilliant. So if you remember, this is the second Jupyter notebook we used in the first training session. The first notebook was more about downloading data and was a kind of repeat of a lot of some of the other training sessions under WEkEO. So what we've done this time is to go through and just make some minor changes to demonstrate to you how we can enhance these basic activities, these basic processing steps that we demonstrated previously. So as you scroll down, you'll see lots of this Jupyter notebook is very similar. So we have some operators at the beginning to just open libraries, etc. Some details of the Sentinel-2 system here. And in this box here, which is labeled number 2, the change we've made is that we're opening up an extra band this time. So we're looking at the green band as well as the red and near infrared bands. And so we'll use that in our processing later down in the notebook. So you can see here that you could add additional, by looking at the format of these calls here, you know you could add in additional wave bands from the original Sentinel-2 image here. So in the first notebook, we displayed just the true color image, but we know there are different ways of representing the data within Sentinel, which has 13 spectral bands. So we can use any of those band combinations to display what has been recorded by the system. So in box 3 here, we can see we have the original piece of code here where we took a pre-constructed true color image here, and then and this displayed that in the image on the left. You can see here that's what we had before. But what we've done on the right is to take what's known as a false color infrared image, where we use the green, red, and near infrared channels of the Sentinel-2 to actually then construct a three band image. And so there's a bit of processing here which goes on to take those original bands and then construct the 3-layer image. And there's a bit of color normalization going on here just to display them through the functions. The functions that are available here. Now, you might see this looks quite dark on here, and that's one of the reasons is that the image we've chosen has a strong difference in color values. So we have the very dark water and the very bright clouds. And so when we make this false color infrared image, the clarity is not particularly good in this very simple display here, but up here we have these normalization functions that allow us to stretch the data within each of the color bands, and so they can be tweaked and adjusted to display the image based on what is best for the image combination. So if this image had just been land with no clouds and no water, then we would have had a much brighter color balance here. But it just this code here is just showing how you would go about taking your original image, building a 3-band composite image, and then displaying it in the same way as we displayed the true color image last time. So the next change that we made, previously we just calculated the normalized difference vegetation index, but that is only one of a huge collection of spectral indices, which take the individual band values within the image and convert them into a indicator of some surface property. And a very similar one is called the normalized difference water index, which uses the green and near infrared bands in order to emphasize the areas that are covered by water in the imagery. So we've taken the code that we used previously for NDVI, and we've just replicated that and generated the NDWI images, this time using the green and near infrared bands. So if you look at the code there, it's very similar. The only thing is we're using different bands now, and we've altered the band math function here to generate the new indicator. So everything else is the same. We're writing it out again to a file, and then we're cropping it to the extent of our area of interest that we used previously. So these are just shows that how we can just copy the file and change certain property parameters in there, and then generate a new output. So in displaying it, again, we've just taken the same display code that we had from before, and we've altered the input data. So this time we're inputting both the NDVI and the NDWI data sets for the masked area, the area of interest, and but also applying a different color ramp. So the NDVI on the left here was what we had in the original Jupyter Notebook. So we've just added this NDWI image here, and chosen a different color ramp. So we know this is related to water. The higher values of NDWI are water surfaces. So we've chosen this time a red to blue color ramp, just to emphasize that. And so we can see here that the blue colors are related to the ocean, and then this lagoon here, which is just behind this kind of barrier island here. But also that we're getting some quite high values from some of the fields along the road here, and perhaps some of the building surfaces are also giving us quite high values. So we can show that we can see here that we can pick out a number of different properties from this indicator. So we have, and then as the value goes down to these sort of minus numbers here, we're then getting into the bare fields, the agricultural area, and also, interestingly, the bare ground of the burnt area that we discussed last time. So we can see here that the burnt areas are giving us just a slightly negative value here. And then the more negative values are, again, as an indicator for water, these are obviously less and less like water. We have the vegetated surfaces here in the uplands that have not been affected by fire. So this is the wooded areas and scleriferous vegetation. And then one final step, we've just replicated the piece of code that drew the histogram for NDVI. So we have now an histogram for NDWI. And if we look at the summary here, we can see the various peaks here related to those different parts of the image that I mentioned above. So the high NDWI image area, high NDWI index image areas are these water features. And then we move down through the different bare surfaces. And then finally, this peak on the left-hand side is the area related to the forest and vegetation. So I hope you can see there that from starting from the original Jupyter Notebook we supplied in the first training session, you can very easily alter the code to generate some new products, some new outputs, and new insight into the surfaces that you're looking at. And by having this framework, then we can then document that and explain what's going on, whether this is in the form of a training session in this case, or possibly a report, or the results of an analysis that you've taken as part of your job or educational activities. So I think I'd like to leave that there now and hand that over back to Vincent, and maybe we can look to see if we have any questions from the audience. Thank you.
Thank you very much, Geoff. Thank you for this summary of this Jupyter Notebook. So, guys, this is a debriefing session, so feel free to type all the questions you need to ask to our experts, Geoff and Amin. So this is an interactive session, and this session is done for that, so feel free and do not hesitate to ask question bottom right of your screen. And there's no stupid question, so feel free to ask your questions. Maybe we can introduce Amin. Hello, Amin. How are you?
Hello.
Hello, Amin. How are you doing? Good?
I'm doing fine, and you?
I'm good.
Okay, so if you have any questions about the Jupyter Hub, or the IT infrastructure, feel free. If you have any issues connecting to your WEkEO account, so don't hesitate to send a message to the support, but we can answer some of the questions also here, so feel free to ask questions. Don't hesitate.
So concerning the IT infrastructure, so what kind of questions are coming on a regular basis concerning the users?
On regular basis, it's more. Sometimes it's some issues with the Jupyter notebook, some whether technical issues or more scientific like issues, and we treat them in a case by case basis. We have also access to all the experts who can respond to any theme or on any question. We have a specific tool to do that.
Okay, good. And so the user support of WEkEO is very reactive, I guess. So
yes, that's the advantage of WEkEO related to other DSs. It's the support section that is very quick. We try to be very quick and efficient on responding to the questions.
Okay, thank you guys, and thank you for your availability. So participants, don't be shy. We have WEkEO experts waiting for your questions. So to leave you time asking your question, maybe I will have some words of the agenda of training webinar. Yes. So quick walk of the next events, which are coming through the first part of 2021. So this is the latest thematic event of the period June 2020 and January 2021. So we have in parallel 8 WEkEO webinars, so which will be scheduled between March and June 21. And they are dedicated to users interested in learning how to process Copernicus Sentinel data using the WEkEO infrastructure. So all the webinars are aimed at both beginners and experts. So I guess this slide sum up well the agenda of webinar we have for WEkEO. So in red, all the webinar number 1, 2, 3, and we are in webinar and 4 is ongoing. No, finished on the 1st of February. 3 more webinars dedicated mainly for webinar are scheduled. The next one is the 4th of March. You will receive an invitation for this webinar, and they are dedicated mainly for beginners. So number 8, number 9, and number 10, 11, and 12, it's more for experts, but we hope that you, the participants, will improve in using Earth observation data using the cloud computing platform WEkEO. So this is basically the agenda for webinars and training, and this is the next one. So for the 4th of March, at the end of this debriefing session, you will have an automatic invitation for this event. Okay, so no question coming yet. So what should we do? Should we wait for you to ask some question, or basically end the session? Because if you don't have any question, maybe we might end the session. So I'm waiting for orders from my colleagues. So if you don't have any question, It means that you are good trainees, and you did your training very well, and the Jupyter notebook was very clear. Thank you, Geoff. Do not hesitate to contact the user support, support at wekeo.eu for any question you need to ask to Amin and Geoff and all the WEkEO user support team. So we wish you an excellent day, and we look forward to seeing you in the next training scheduled the 4th of March. Thank you very much. Bye-bye.